Good morning, students. This is the course on programming and data structures, and Professor Shankar Balchandran has already taught you programming in C, and I will be teaching you data structures and algorithms in this part of the course. So, first what we will do is, as part of this course, before we go on to data structures, we will first do a basic recap of the building blocks for programs. Especially we will look at the control structures which you have already studied. We will just do a recap, we will do a little formally. We will also look at arrays and functions, which are where arrays are data structures that are already available in C or C++ or Java or whatever, and also recursive data structures which are available for you to work with in programming languages. You already studied this, but we will just recap that. And then once you write a program, we want to see how efficient a program is, okay? How well does it work on a particular kind of input data. So, we will study complexity analysis, and here what I will do is I will give some kind of formal way of finding the complexity of programs. There are rules called the sum rule and the product rule, which we will learn in great detail. We will also analyze recursive functions. Then we will also recap basic sorting and searching algorithms. We will look at primarily two types of sorting algorithms and two types of searching algorithms. Then once we have done this, and by then we are equipped with the ability to analyze programs in a big way, we will start defining what are called abstract data types. What are abstract data types? There are special types of organizations of data structures and programs which make an abstract data type, and these abstract data types are actually user defined. And why do we do this? Primarily because we define operations on abstract data types which can be done in a very efficient way for problem solving. Tree is another abstract data type. For example, if I want to represent my family tree, I would need a different kind of a data structure, and we will define operations in the tree. I want to find who is a grandparent and who is a grandchild and so on and so forth. So, you need a specific data structure called the tree with operations defined on it. Then we will define what are called priority queues, which are queues similar to the queues that we see originally, but with priority added to them. Then we will do data structures on hash tables, where we would like that any operation can be performed very quickly. And finally, we look at graphs. For example, if you look at the internet today, internet is actually a graph of nodes that are connected together. So, if I want to do any kind of analysis of the network, I need a graph abstract data type, and we will talk about that. So, let us look at the recap of basic programming. You already learned problem solving using C. So, you might have heard or might not have heard of this. So, basically what we talk about is here is when you are given a problem to solve, you define what is called an algorithm to solve the problem. What is an algorithm now? It is a prescription to solve a problem which, provided it is faithfully executed, yields a result in a finite number of steps. That means, what am I going to write? I am going to, it is like a recipe to solve a problem, and the recipe is such that if it is followed verbatim, it will solve the problem in a finite number of steps. I like to define programming as, borrowing from Rugono, it is a means to translate the sequence of steps that you have written in some kind of English like sentences in a sets of instructions that can be understood by the computer. For example, what we are trying to do here is we are separating algorithm and programming here. An algorithm is written in an English type of statement, whereas a programming is done in a particular language, C or C++, Java, Python, whatever it may be. Here is a functional specification of a program that I have given. This is something that I advise all my students. When you write a program to solve a problem, I would say, instead of just going to the computer and start keying in right away, first thing that you have to start looking at is define a name for the program. What does it solve? Give it a name. Then you it is like making a recipe to bake a cake or whatever it may be. You have to find the ingredients. What are the ingredients here? The declaration of local variables. Then to solve the particular problem. Then you define what are called on the local variables, what are the conditions that must be satisfied by the local variables so that the program will run as expected, that is called a precondition. Then you give the body of the program, which is again a set of instructions. Then after the program is executed, what is the post condition? What is the result or the goal that you expect to reach? Okay. So, first I would say that give the name of the program, the declaration of local variables, precondition and post condition, and then you set out to write a program which solves this. So, let us take a specific example now. Let us take, I want to write a program to exchange, I am sure you have already seen this, two variables x and y. Let us assume x and y are integer. So, what is the functional specification say? I will write this in C, although ideally you should write it in English like statement. So, you give the program a name, program exchange. This is the name that is given to the program, and I am writing the main program, main, and integer. I define the local variables now, x comma y. If I want to effect this exchange, I will need a temporary variable, unless I want to do a more efficient program which does not use a temporary variable. Then maybe I want to read the values, x ampersand y. Of course, I am assuming that you have included standard IO dot h. Okay. Then what do? We assign temp equals x and x equals y, and then y equals temp, and that is the end of the program. So, now what do I need now? I need to know what is the precondition on this. X and y are arbitrary. That means it can take any values, and what you see as the post condition, the values of x and y are interchanged. Okay. You have already seen this statement. So, you look at what is the body of the program here, scanf. This is not relevant to the exchange process, we are just reading the variables x and y. So, this is the main body of the program, and what are these statements? This is a particular control structure that is available in any programming language, and it is called the assignment statement. You can write very large programs with simply assignment statements. For example, what is an assignment statement now? In general, it is a variable on the left hand side of the equal sign in C, and on the right hand side it can have an expression and so on. This is an arithmetic expression. I can also have suppose x equal to 0, I can also write y is equal to not x, then it becomes a Boolean expression. So, you can write large programs simply writing the assignment statement itself, but there is a bit of a drawback with this, because all that I can do is simply expression evaluation, whether it is an arithmetic expression, logical expression or whatever. Now, suppose now I want to modify this and say I want to exchange x and y only if x and y are both greater than 0. Then what do I have to do? I have to make a change to the body of the program. What do I do to the body of the program? I say if x greater than 0 ampersand ampersand y greater than 0 to flower bracket, then these statements will be executed. Y equal to 10th. Okay, we'll do this. Then what happens now? My post condition also is changed. So what does the post condition become here? The post condition will be x and y are exchanged if both x and y are greater than 0. Okay. So you need to, whereas the input condition on the other hand is still remaining the same. So this is how I would expect you to do this, and as you keep on increasing the sizes of programs, for every small segment it's nice to put a precondition and a post condition to show what you expect. Now what I could do is, this is an if statement over here, and this is a new type of a control structure which you have already seen. It's called alternative statement, sometimes also known as a selection statement. Now clearly the alternative statement is need not be only one alternative, they can be a number of alternatives. I could say x greater than 0, y greater than 0 do one thing, x greater than 0, y less than 0 do something else, x equals 0, y equal to 0 do something, and so on. Then all these can be written if condition 1 body of program, let me call it program 1, then else if condition 2, then you have another body of the program, else if condition 3, and so on. You can keep on extending this to a large number of alternative statements. So the alternative statement is a very powerful statement using which you can satisfy a large number of conditions that may be there on the input data. Notice that, and every time what I will advise you to do is, in every case for every small piece of code, write what is the input condition, what is the output condition. Okay. So this is the alternative statement. The next statement which you have already learnt is what is called the repetitive statement. Suppose I want to perform an operation a number of times, then we use what is called a repetitive statement. Let me give you an example, a simple for block. Statement that is made up of a for block plus let us say n is equal to 10, and I have initialized sum to 0, sum is equal to sum plus I. So what do we have now? What does it tell me here? This for statement says for I equal to 0 and while I is less than n, that means this is the initial value, and till it reaches the final value of n, just increment I by 1 and compute sum of I plus I, sum plus I. So what have we done here? We are just computing the sum of the first n numbers starting from 0. So this is a simple form of a repetitive statement. Now what I am going to do is, I am going to take you a little further, and let us look at this. You have already done the greatest common divisor and in the programming part of the course, and we will see how you learnt about the Euclids algorithm there, and we will put this in the form that I have been talking about. So what is the greatest common divisor? All of you know what it is. Let us just recap again. Suppose I have two numbers, one is of size 30, another is of size 18, and let us say I want to find the GCD of 30 and 18. GCD is also the highest common factor between these two numbers. You have done this in school. What did you do in school? You took the number 30 and said, let me write it in terms of its prime factors. All of you know what a prime number is. Prime number is 1 which is divisible only by itself and 1. I take 18 also, write it in terms of its prime factors, 2, 3. All right. Then what would you do? You would cross out the common terms in both the numbers. This is 2, common terms in both the numbers, multiply these two, and you will write that 6 is the highest common factor or GCD of the two numbers. Now, what we will do is you already done, I guess, Euclids algorithm. Let us just recap it. It is a slightly more efficient algorithm. When you put it on the computer, what we normally do is the following, as indicated in this program here. We take 30, we divide by 18, we get the value of 12. Okay, so let me say this is 12. Then what do we do? Then we divide 18 by 12, this will give me 6, and then I divide 12 by 6 and the remainder becomes 0. That means I have found the greatest common divisor. So, to recap again, I take the number 30, divide it by 18, then what happens? The remainder is 12 which I have marked here. Then I take the smaller two numbers 18 and 12, I divide 18 by 12, then the remainder is 6, then once again I take the smaller of the three numbers, just 12 and 6, I divide 12 by 6, the remainder becomes 0. So, once the remainder is 0, we are done. This algorithm is called Euclids algorithm for computing GCD. Okay. So, what have I done here? I have written this in C over here. So, notice that this is a different form of a repetitive statement. We are saying do until remainder is m% n and m is set to n is set to the remainder, while remainder not equal to 0. So, what will be the precondition? M and n have to be non-zero positive integers, and what is the post condition that is satisfied? That you found the GCD of m and n. Here is another way of writing this same program using another type of repetition statement called while m not equal to n, if m greater than n, then you keep on reducing one number by the other until it becomes equal to, until both the numbers become equal. When the two numbers become equal, it will give you the GCD of the two numbers. So, what have we done here? Notice that within this do block, you have a set of the body of the program consists of a set of assignment statements. Here within the while block, here for example, there is an alternative statement, and within the alternative statement there is an assignment statement and so on. So, what we have done is we have looked at the basic building blocks of programs, assignment statements, alternative statements, repetitive statements, and what did we do? We basically kept on adding complexity to the way we wrote programs such that all these statements were being used. Okay. Next, what we will do is, so this is all very fine. What did we do now? So, basically if you look at your program now, a large program can be written with the assignment, the alternative and the repetitive statement. Now, it would also be very nice if you can have two things. One is, I want to write a program which generates long lasting computations. I also want a program which can process arbitrary quantity of data, and you have already seen in the programming course how do you do this. Yes, you guessed it right. We need a function module and the data must be stored in an array. Okay. So, basically what we are looking at is a program segment that refers to a state space of an arbitrary number of dimensions. Using arrays and functions, program segments can be made to process an arbitrary number of dimensions of data. So, here is one example again. You already know what an array is. I want to reverse the elements of an array. So, I have written one function here which will which we already saw the swap for example. Here it is done with a function, for example I am taking an argument to characters and I want to reverse the string in place, that is the objective. So, that means I have a string like this, let us say I want to write a program of this kind where I am taking a string I have a string like this and I want to produce this output. I want to do it in the same array. Okay. Let us say this is the array A. So, this is 0, 1, 2, 3, 4, 5 and this is again the same array A. I want to do this in place. So, how do we effect this? We simply exchange the first two elements, the next two elements and then the middle two elements, and that will give us the string, and that is what this piece of code is doing. The exchange operation is being done by this swap over here, and you already know why we have to pass it with the as a pointer, for the simple reason that C does not support pass by reference, it only supports pass by a value. So, basically the contents of x location pointed to by x are exchanged with the contents of y, but basically the addresses is what we return back to the main program. So, this is the program, and what are we doing here? As I said, I come to the divide the array into till the middle, for example, until I start from here, exchange this, here exchange with this, here exchange with this, and then once I have reached the middle of the array, I am done, and that is precisely what this program is trying to do. Okay. And what are we doing? Till length by 2, I am swapping the two elements. Swapping means exchanging the two elements in the array. Now, you have seen in the programming course that you could use arrays, or you can also use recursive data structures. What is the recursive data structures now? I can use, for example, I want to represent, as we said, we want to do some long lasting operation, right. So, I can write it like this, ST R I N and G. Okay. So, now let us say I want to do the same operation as I did here in this, where I reverse the array. And so, what do I want now? I want a reversed list, this also done in place, such that this is the header that I have. You know that already in a recursive data structure, it has a header to which points to the starting point in the list, in the linked list. And now, what do I want to do? I want to make this the header and reverse all these arrays, okay. And finally, this should point to the tail, okay. And that is exactly what is being done in this program which I show you over here. So, what are we doing now? We have 3 pointers P, Q and R. What are we doing now? We are first setting, so the pointer Q, let me call it Q is a pointer which is set to null, that is how we started. P is the pointer which is pointing over here. Then what are we doing? We are saying while P does not become null, we are putting R. So, R is pointing over here, okay. R is pointing to P pointer next. Then what are we doing? We are saying P pointer next now is going to point to Q, okay. What is Q pointing to now? Q is pointing to null, right. Then, so what have we done now? I have made R point to P pointer next, and the next element of S is pointing to null. Next, what are we doing? We are setting P is equal to R, because I already have a pointer Q which points to this. Then we are setting P equal to R. Before that, of course, we are setting Q equal to P, because Q is updated over here, and we are setting P equal to R. So, R is the, so this is the new P pointer now. Then what do I do? So, basically I have a Q which is going like this, and this no connection over here, and P is passing through this. Then what do I do now? Once again I repeat the same process. What will I do now? I will put there, basically I will put R is P pointer next, R goes over here. Then what will I do? I will put P pointer next is Q, then I will update Q to the position where P was, and then I will make this P again, and you keep doing this until you reach the end of the list. So, this is another implementation of the reverse string which is done in place. So, what we have looked at so far is we looked at basics of programming, basic building blocks that make up a programming language. Then we looked at the arrays and functions with some examples on reverse string using the array and also reverse string using the linked list. And these are, so now we are kind of equipped with what are called the basic data types. What are the basic data types we have? We have the integers, we have the floats, we have the character, and then in addition to that you have structures like this. For example, recursive data type is represented using a structure and a pointer for that matter, and then you also have the arrays. So, next what we want to do is we have written now, so basically we have started writing programs which execute a number of times. Now, let us say I have 2 ways of solving the same problem, or maybe 4 ways of solving the same problem. How do we know how well this program runs? So, we need to get some formalism into how you analyze algorithms. Okay. So, we will stop here and we will go on to the next lecture on to determine the efficiency of algorithms.